Okay, guys, we are going to work on continuing on with subatomic particles, protons, neutrons, and electrons, and we are going to start building atoms with them. And so what do I mean by that? Well, we have two different types of atoms that we're going to be looking at. We're going to be looking at ions, which are, we're just going to say atoms with a charge. So that could be a positive or a negative charge, so atoms with a charge. Or we're going to be looking at isotopes. And so isotopes, I-S-O-T-O-P-E-S. Isotopes are atoms with different masses. Atoms with different masses. And we're going to do some examples here in a second, but I'm going to use these two vocab words kind of repeatedly, is that we're going to start building some atoms. Sometimes we need to build an ion. Sometimes we need to build an isotope, which would be the same atom or same element with different mass. Okay, all right, let's get going. So what we did is, kind of before this, we learned that there are three subatomic particles. You have protons, neutrons, and electrons. Protons determine what element you have. So if I got, 3 protons right here, let's go ahead and click stable, unstable. We have lithium. So lithium right here on our periodic table has got a 3 on the atomic number, so it tells us we have lithium. As far as neutrons go, that helps us determine our atomic mass. So lithium what? We've got, lithium 6 is our isotope. So if we were to kind of do some examples right now, we got, lithium 6-6 tells me that we have 3 protons and 3 neutrons. However, if you notice up here, it says plus ion, meaning this has a charge, and it should, because we have 3 protons, 3 positive pieces, and 0 electrons. So, on your periodic table, I'm going to give you 2 things to write down. One's going to help you figure out your number of neutrons, and the other one's going to figure out your number of electrons. So, on your periodic table, somewhere in the corner, write atomic mass, so AM equals protons plus neutrons, because your mass is determined by what's in the nucleus of an atom. All right, and then charge, so we got atomic mass equals protons plus neutrons, and then charge equals protons minus electrons. Oh, let's do an E there, not a 3. Protons minus electrons. And this is really going to help us when we determine what we need to figure out as far as playing the simulation portions of building an atom. So, let's go back to the atom we have on hand, and that is a lithium plus ion. Notice it's got a +3 charge because there's no electrons. So if we add a couple electrons, notice that protons and neutrons go on the inside. Electrons are on the outside in the cloud. And since I have 3 positive pieces and 3 negative pieces now, it is balanced. We see it has a 0 charge, has a mass of 6, and there we go. We're kind of done. So what I'm going to do is I'm going to go through a couple examples with you on how to walk through this game. All right. First example is we're going to rebuild lithium we had earlier. So we had lithium, 3 protons. It had 3 neutrons and had 3 electrons. Now the numbers not are always going to be the same, because usually somebody's like, well, it's always going to be, if the first number's 3, then the rest of them are 3. That's not always the case. Let's see that. Sometimes you have lithium that has 4 neutrons. So, what do I have over here on the right side? Notice my atomic number, the number of protons, is on this bottom left-hand corner, and my atomic mass is on the top left-hand corner. Charge is on the top right. We're going to use that as kind of a reference point when walking through this activity. Okay, let's do a couple of example problems together. So, first thing we're going to do is find the element. So we see that we have 7 protons. So I'm going to find on my periodic table, the one you've colored, something that has 7, the atomic number of 7, and that's going to be nitrogen. Okay. how many electrons does it have? Well, we notice we have 7 protons and 10 electrons. Is that number the same? So if we use our formula we just wrote down, so charge equals protons minus electrons. We have 7 protons minus 10 electrons. Our charge is -3. So, is it neutral? No. It has a charge of -3, which makes it an ion. There we go. Okay. Find the element. So the first thing we're going to do is we're going to look at the number of protons we have. We have 2 protons. So that means we have helium. And is it neutral or does it have a charge? Well, we have 2 protons and 2 electrons. 2 positive pieces, 2 negative pieces. It's going to be neutral and done. Okay. I'm going to start over and I'm going to go to the next example here. So for this kind of question, it asks us, what is the charge? Well, to find charge, we're going to use the formula we just wrote down. Charge equals protons minus electrons. So 5 minus 5, which is 0. So what is the total charge of this atom? 0. What is the mass number? So that's our atomic mass. So atomic mass, Am, equals protons plus neutrons. So it's going to be 8 plus 9, which gives me, we're going to count with our fingers if we want to, 17. Okay. So we're going to go up here, all the way to 17. Looks great. Done. Okay. I'm going to go ahead and click start over. Let's do a different one. Okay. This one gives us some pieces. We got to fill in those last pieces. So this one's only asking for the atomic number, which is your number of protons. See how this is orange and this is orange? So bing, done. Okay. So this is atomic number. Atomic mass is 35. What is the charge though? If we use that formula we just wrote down, this stuff's pretty easy to figure out. You just got to look at what you're going for. So we got looking for charge since it's in the top right. That means we have 17 protons, 17 electrons. It means the charge is 0. Looks pretty good. Okay. And then let's do some of these last two. So here's where things get a little bit tricky and it kind of wraps it all together is you're going to have to put the whole thing together. So we're going to have 16 protons. So we have sulfur. To find your atomic mass, that's going to be, so let's write it in, atomic mass equals 16 plus 16, since we have 16 protons and 16 neutrons. That's P plus N. There we go. So atomic mass equals 32. What about our charge, though? Charge equals protons minus electrons. So 16 minus 18, which is -2. I guess I should write the final answer there. So we got atomic mass of 32 and a charge of -2. You can hold down, it'll go all the way up. Looks good. Okay, what I want you to do is I want you to pause on this video, try this one out, and see if you get the same answer as me. Did you pause it? All right, let's try it out. All right, we got atomic number 7, so that means we have 7 protons. We have an atomic mass of 14, so that means 7 plus something needs to equal 14, so 7 plus 7 gets you 14. And number of electrons. Well, if we had 7 and 7, those would cancel out to 0. So, charge equals protons minus electrons. So, we want -3 equals 7 minus E. I'm going to subtract 7 on both sides. And so I get -10 equals -E. We will drop the negative, so let's make both sides positive. So we need 10 electrons. And that makes sense because if we want a charge of -3, we need more negative pieces. Okay. All right, let's do this last one, and then we're going to call this done on this video, and you should have enough information to get going. So we got 1 proton. Atomic mass is 1, charge is 0. Oh, I hit start over, and then it said we'll never know if it's correct. Okay, here's what I want you to do. We now should know the difference between carbon-14 and carbon-12. Those are atomic masses. So carbon-14 and carbon-12, they're both going to have 6 protons, but different number of neutrons. Tell me what those numbers are. Okay. What do carbon-14 and carbon-12 have in common? Well, what kind of hinted already is that they would both have the same number of protons because carbon is always going to have 6 protons. And list the number of protons, neutrons, electrons for lithium plus ion. It's got a +1 charge. So if you follow along the video, you should be able to figure that out with me. Okay, as far as that building atom simulation, there's the link right here. Takes you right here. I want to see 4 stars for all 4 of these levels. Okay, as far as relative abundance, you actually aren't going to be doing that. So what I want you to do is you can actually highlight it and delete it, and only have to do this bottom portion right here. So I'm looking at is for the pre-lab or pre-activity, a screenshot of your levels finished, and post-activity questions. All right. Someone you actually get to Google. So talking about decays and what makes stuff decay as far as atomic radioactive decay. Okay, that's it gonna be for this activity. If you got any questions, feel free to reach out. Send me a screenshot of the one you're stuck on, and I'd love to help you out. Take care, and I'll see you guys next week.